Hello, my name is Endergus. I will talk about now. This chart is show us the 5 most frequent words in popular songs title. These are you, me, know, love, and live. You and me are related with personal relationships. Love and live are related with emotions. Let's talk about feelings. Everyone has feelings and falls in love with someone. So these words for everyone. And using these words in a song title, it makes anyone a potential listener and increases potential audience. This chart is about duration of song types. Two of them have a duration of over 300 seconds, one of them under 150 seconds, and others mostly between 200 and 250 seconds. So we can say that average duration of popular songs is around 3 and 4 minutes. If you want to increase the song streams, you should pay attention to the song duration. This pie chart is about top streams by regions. We can see that United States is the country were the most music listened to, but China is the most crowded country in the world. Why we cannot see China on this pie chart? Because Spotify is not available in China, so we can say that United States is the best country. Second one is Brazil, third one is Mexico, Germany, and it goes on. Now I will talk about with codes. We first import the libraries that we will use. We choose to delete the rows with missing values because the dataset is very large and we decide that this will not be a problem. The numerical data is stored with dataset as string because the values are very large. We convert these values to integers. And we calculate the average number of followers and define the values above it as high followers and the values below it as low followers. We create a scatter plot for comparing the number of followers to the number of streams for artists with high followers and low followers and fill the labels. And this is a correlation between followers and streams. We specify the column and read the CSV file, and we create a bar plot to show the duration of song type and fill the labels. And this is the bar plot. We specify the column and read the dataset again. We remove the missing values and split the track names into individual words and count the frequency of each word. Here there are a lot of meaningless words in song title, so we will remove all of them. And this is the bar plot of words frequency of song titles. We select row from the data frame where the chart column has a value of top 200 and the rank column has a value of 200 or lower. We make a group top 200 data frame by region and sum the streams for each region. As you can see, there are globals and others here. We delete them because they are not unnecessary. And here we delete them. This is the last version of pie chart. Thank you.
Hello, my name is Gizem. We are Team Poliwag, and this is our project, Spotify Analysis. We choose this topic because, as we all agree, Spotify is one of the most popular song streaming platform, and millions of people listen to it every day. Some of are just listening to songs, and the others are make money by share their songs in this platform. Our goal is to analyze the listening rates of the songs for these artists, and we want to analyze the listening rates of the songs and prepare a report on what people who want to be famous and make money should pay attention to. So we are looking for an answer to the question, what are the factors that increase streams on Spotify? In this heat map, we can see the relationship between each factors. And this is the most popular 5 genres. Dance, pop, rap, and hip hop are well known for everyone, but reggaeton is not like them. Reggaeton is only popular in Spain. Portugal, Central and Latin America, but this is enough to make it the 5th most popular music genre. Now I talk about the codes. Here I import the libraries, and then I load the dataset and print the dataset infos to see the dataset context. And then I calculate the average valence of top 2000 songs, and this is the result. And then by grouping the year and valence factors of the dataset, I found the average number of valence by years. Then here I created a line plot with this information, and here the average number of valence for each year. And then I make a heat map. In this heat map, each square shows the correlation between the variables on each axis. Correlation ranges from -1 to +1. Values close to 0 indicate that there is no linear relationship between the two variables. Values close to 1 represent a linear relationship, while values close to -1 indicate an opposite relationship. And when we look at the table in here, we can say there is a linear relationship here because the values in the intersection of energy and loudness is very close to 1. And then when we look at here, we can say there is an opposite relationship between energy and acousticness because the value is very close to -1.
Hi, my name is Abdussamet and I'm going to talk about how our model works, what inputs we give it and what outputs we get out. So we are using one data set called Spotify Futures, but this is a 32 megabytes data set which contains all the songs uploaded to Spotify from 2010 and 2019. So it's a pretty big data set. We discovered that these 5 attributes are actually the most impactful when it comes to a song's popularity. So we are feeding these 5 attributes to the model and we are hoping to get an accurate popularity. So we split the data into training and test sets here from 80 to 20. Whoops. What did I do? Anyway. So we define the base models here, random forest regressor and a linear regression. In a linear regressor, we train them, we make predictions with them, we print the accuracy of these models. Because they are not classifiers, we can't just use accuracy score, so we have to use mean absolute error value of these. Then we combine the predictions from the base models and use them as the input to the meta model, which is also a linear regressor. And after that, we convert the predictions to binary labels because just trying to predict the popularity was not good. We'll get to that in a second. We made the predictions, and then we print out the accuracy score. The accuracy, precision, recall, and F1. As we can see, because we use regressors, because we use 3 regressors to make a classifier class, so a classifier model, our accuracy and precision is really good, but our recall is kind of low, which means it has a bit of a false positive problem. But like I said, that's probably because we used 3 regressors to make a classifier. And I want to talk about our first model that I talked about in class, which had an accuracy of -8.26. It's because we calculate the accuracy like this. We first calculate calculated the mean absolute error, and then we subtracted that from 1, which kind of made sense when we first thought about it. But yeah, that's the reason why this accuracy occurs. So yeah, thank you for listening.